This problem is asking to solve for V, which is the electrical potential difference between one node and another. What is a node? A node is a common point between two elements or more. So we have a terminal here for each element. So in this case, each element has two terminals. So a shared point between those two terminals, that's a node. So this is one node here, another node there, another shared point here, and a shared point here. So this circuit has 1, 2, 3, 4 nodes. For this problem, to solve for V, we're going to be using
mesh analysis.
What is a mesh? A mesh is a loop that has no loop inside of it. So this is one loop here. This is another loop. But also there is a loop around the entire perimeter of this circuit. But only two meshes. Because again, a mesh is a loop that has no loop inside. Passive sign convention. We're going to be adhering to the passive sign convention, which means that it's a current that passes through the voltage difference. It's always entering the positive and it's always exiting the negative. So this is our circuit. First step, I'm going to reference the ground node. So this is 0 volts. In this entire node, it's 0 volts. The problem is asking to solve for V, which is the potential difference, electrical potential difference right there across the 68K resistor. My next step is to assign an orientation to the mesh. So we have two meshes in this example. The first mesh, the orientation is arbitrary. For example, I'm going to pick clockwise. If I pick clockwise for one mesh, I must adhere to the same orientation as any other meshes that I have. So if I pick this orientation, my passive sign convention goes this way. Had I picked, for example, counterclockwise, my positive sign convention would have been this direction. Because again, as the current passes, it enters the positive and it exits the negative, and that's the passive sign convention. For this example, I'm going to pick clockwise because I can. So I'm going to call this mesh I1. This is my sign convention here. And the next mesh, I'm going to call that mesh I2. And my positive sign convention for this here, or passive sign convention, is this way. So for the first mesh, it doesn't matter where you started. I'm going to pick the first mesh and I'm going to start from here. So as this current passes through here, because the current is going to be going around in this orientation. So the first element is going to be that voltage source. So I'm just going to say this is my first equation. It's, as you can see, it's against the sign convention because it's entering the negative and it's exiting the positive, which means I'm going to say that's a negative 4.2 because it's against our sign convention. That's the first, and then the next element of that mesh is the 20 20K resistor. Now this is entering the positive, so that's a positive 20K and times the current, which I1, because voltage is resistance times the current. And then the next one is here. So this current is coming this way. But the current I2, because this is being shared between the two meshes. So, but this current is going against my reference, which means I2, I'm going to denote that as plus 68K I1, and then the one going against my reference is I2, which is going to be minus. And all of that equals to 0 because I finished my loop, my mesh. For the second mesh is I2, and I'm going to start here. So I got my 68K, so that's 68K. I2 is my reference, but this time I1 is going against my reference, and I denote that as minus I1. Next element is here. The current comes through here, plus 47 KI2, and the last element in this, as you can see, it's entering the positive and exiting the negative, which is in accordance with our passive sign convention. Plus 2 volts equal to 0. We have two equations and two unknowns. And this current here, we have a junction here, which means this current that comes through here is going to split here, and it's going to split here. And this current that splits right in the middle, I'm going to call that IM. And IM is simply, it's going the same direction as I1, but it's going at the opposite direction as I2. So IM is I1 minus I2. And V, in this case, because the other node is 0, V is equal to IM, which is I1 minus I2, times the resistor that is right there, because voltage is current times resistance. And I'm going to solve this in MATLAB using the plugin called Symbolic Math.